Hello, my name is Ashley Sibley. My article, How Big is the Biggest Prime Number, was written by R. Scott Williams and can be found in Math Horizons. It caught my attention because I've always been interested in primes. My favorite prime happens to be the number 2. And you are math people, so you can only guess 2 because it's even. In the article, Williams discusses the primes and research surrounding finding the next largest prime. He gives us some visuals, and if you'd like to read the article yourself, it's a very quick read. The largest known prime is given there. It's a Mersenne prime, and he tries to give us some frames of reference for how large this number is within the article. There are several different types of primes given, and we will look at a chart that includes their representations. My favorite part discusses the research that is ongoing to find the next largest prime. And if you would like to be able to say that you participated and helped find the next largest prime, you can join GIMPS, the Great Internet Mersenne Prime Search. You lend your computing power, and they use it to find the next largest prime by using a computer program. Although, with all of the computing power out there, you would think they would have found more primes by now. This chart shows 1996 to 2018, where they found several primes. There's some discussion as to whether or not there may be a gap in the primes between numbers 47 and 48, that possibly there were some numbers skipped within there, and we may find another prime somewhere along between 47 and 48. In history, we see the greats, such as Euclid, talk about primes. He says there are infinitely many primes. And he also gives us the fundamental theorem of arithmetic, saying that integers can be written as the product of primes. I think that's where my fascination with primes started, in elementary school doing prime factorization trees because they were just so pretty. We also have Eratosthenes, and in class this semester we used the sieve of Eratosthenes to find prime numbers, I believe from 1 to 100. We also have primes concerning Fermat's little theorem and some other mathematician greats, such as Euler and Gauss. Here's the chart that gives us the types of primes, their representations, the number of digits that the largest of that particular type has, and the form that is used whenever we talk about those primes. If you'd like to try your hand at finding one of these primes, you can use the form, or you can even use a computer to find it. Again, he's giving us some type of reference for just how large the largest prime number is. He tries to compare with Legos, pages in a book, and with atoms. This table shows us the thickness of a book that would span the universe is only 2 to the 104th pages. Compared to the largest prime, this is very, very small. Mersenne primes take up the first 8 slots in the largest prime race, and that's followed by a Proth prime at number 9. You can see from the chart that the number of digits for the largest prime, or the largest Mersenne prime, and the largest Proth prime are very, very different. 24 million compared to 9 million, that's vastly different. Again, he uses examples of Legos, book pages, and atoms to try to describe just how large the largest Mersenne prime is. But still, these comparisons are so very, very small. And if you would like to find the article, you can find it in Math Horizons to read. Again, I enjoyed the article. I thought it was well written. It covered a lot of material very succinctly and allows you a look into what the research currently looks like. And of course, within our course, you can always look back at where primes began in math history. Thank you for your time.